If we have any two given points, we can find the point that is exactly in the middle of them. We call this point the midpoint, where mid means middle. To find the midpoint, we use the following formula. To find the x-coordinate of the midpoint, we say x1 plus x2 divided by 2. And to find the y-coordinate, we say y1 plus y2 divided by 2. Once again, x1 and y1 are the x and y coordinates of one point, and x2 and y2 are the x and y coordinates of the other point. It does not matter which point you assign as point 1 and point 2. The midpoint will be the same. Let's look at some examples. Find the coordinates of the midpoint P on the line MM between points M, 1, 1 and N, 3, 5. Our midpoint is P, so we can say P is equal to, let's say that M is our first point and N is our second. Now we can open a bracket. For the x-coordinate of P, we look at the x-coordinate of M, which is 1, plus the x-coordinate of N, 3, over 2. Then for the y-coordinate, we look at the y-coordinate of M, 1, plus the y-coordinate of N, which is 5, over 2. And now we can close the bracket. Now we can simplify the terms in the numerator of the fraction. We can say P is equal to, let's open a bracket, 1 plus 3 gives us 4, over 2. And for the y-coordinate, 1 plus 5 is 6, over 2. And now we can close the bracket. Finally, we can simplify our fractions. We can say P is equal to 4 over 2, which is simply 2. And for the y-coordinate, 6 over 2, which is 3. These are the coordinates of midpoint P. Let's do another example. Determine the midpoint T of line segment PQ, where P is -5, -4, and Q is 0, 6. Let's say that P is our first point and Q is our second. Our midpoint is T, so we say T is equal to, open a bracket, the x-coordinate of P, -5, plus the x-coordinate of Q, 0, over 2. And for the y-coordinate of T, we say the y-coordinate of P, -4, plus the y-coordinate of Q, which is 6, all over 2. Now we can simplify the terms in the numerators of the fractions. So we say T is equal to -5 plus 0. Let's open a bracket. We get -5 over 2. For the y-coordinate, -4 plus 6 is 2. So we get 2 over 2. And now we can simplify the fractions. So we say T is equal to, let's open a bracket, -5 over 2 cannot be simplified. So the x-coordinate of T is -5 over 2. But 2 over 2 is actually 1. We can say 1 and close the bracket. So the midpoint T has coordinates -5 over 2 and 1. Let's do one more example. If P with coordinates -7, -1, and Q with coordinates 3, 11 are given, determine the midpoint of PQ. Now in this case, we haven't been given a letter for the midpoint. So let's call it M. So we can say that P is our first point and Q is our second. Now for the midpoint M, we can say M is equal to, let's open a bracket, the x-coordinate of our first point, -7, plus the x-coordinate of our second point, which is 3, all over 2. For the y-coordinate of M, we look at the y-coordinate of P, -1, plus the y-coordinate of Q, which is 11, all over 2. And now we can close our bracket. Again, let's simplify the terms in the numerator of each fraction. So we say m is equal to negative 7 plus 3 gives us negative 4. So we can say negative 4 over 2. And for the y coordinate, negative 1 plus 11 gives us positive 10 over 2. And now we close the bracket. Finally, let's simplify our fractions. So we say m is equal to, open the bracket, negative 4 divided by 2 is negative 2. And 10 divided by 2 is positive 5. So the coordinates for midpoint M are negative 2 and 5. As we have seen in these examples, if we are given 2 points, we can find the midpoint between them. But with this formula, we can also find the coordinates of an unknown point if we are given the midpoint and another point. To make this easier, let's look at some examples. A line joining A with coordinates negative 2, 4 and C with coordinates x, y has the midpoint T with coordinates 1, 3. Find the values of x and y. In this case, T is the midpoint of A and C. We have the coordinates of point A and the midpoint, but we need to find the coordinates of point C. To make it easier, let's look at each coordinate independently. Let's start with the x coordinate of C. Now, from the formula up here, we can see that the x coordinate of the midpoint is equal to the x coordinate of our first point plus the x coordinate of our second point divided by 2. So in this case, we can say the x coordinate of t, let's call it tx, is equal to the x coordinate of our first point plus the x coordinate of our second point all over 2. Let's say that A is our first point and C is our second. So we can say the x coordinate of t, which we see as 1, is equal to the x coordinate of our first point, negative 2, plus the x coordinate of our second point, x, all over 2. And now we can solve for x. Let's multiply both sides by 2, and we get 2 is equal to negative 2 plus x. To get x by itself, let's add 2 to the left-hand side, and we get 2 plus 2 is equal to x, which means that 4 is equal to x. This is the x coordinate of point C. Now let's find the y coordinate. We know that to find the y coordinate of the midpoint, we say y1 plus y2 divided by 2. So the y coordinate of the midpoint t, let's say ty, is equal to the y coordinate of point 1 plus the y coordinate of point 2 all over 2. The y coordinate of the midpoint t is 3, so we say 3 is equal to the y coordinate of our first point, A, which is 4, plus the y coordinate of C, which is simply y, all over 2. And now we can solve for y. Let's multiply both sides by 2. 3 multiplied by 2 is 6, so we get 6 is equal to 4 plus y. Let's move 4 to the left-hand side, and we get 6 minus 4 is equal to y, which means that 2 is equal to y. Now we have an x coordinate of 4 and a y coordinate of 2. So the coordinates for point C are 4, 2. Let's do another example. The line joining point C with coordinates negative 2, 4 and point D with coordinates x, y has a midpoint M with coordinates 1, negative 3. Find the coordinates of point D. Let's start by finding the x-coordinate of point D. We know that the x-coordinate of the midpoint M, let's call it mx, is equal to the x-coordinate of our first point plus the x-coordinate of our second point divided by 2. The x-coordinate of our midpoint M is 1, so we say 1 is equal to, let's say that C is our first point and D is our second. The x-coordinate of C, -2, plus the x-coordinate of point D, which is simply x. We put this over 2. Now to solve for x, let's multiply both sides by 2. 1 multiplied by 2 is 2, and we make this equal to -2 plus x. To get x by itself, let's move the 2 across. We get 2 plus 2, which is 4, and this is equal to x. This is the x-coordinate of point D. Now let's find the y-coordinate of point D. So we can say the y-coordinate of the midpoint M, let's call it my, is equal to the y-coordinate of point 1 plus the y-coordinate of point 2 all over 2. The y-coordinate of our midpoint M is -3, so we say -3 is equal to the y-coordinate of point C, which is 4, plus the y-coordinate of point D, which is simply y, all over 2. And now, to solve for y, let's multiply both sides by 2. -3 multiplied by 2 is -6, which is now equal to 4 plus y. To get y by itself, we have to move 4 to the left-hand side. -6 minus 4 gives us -10, and this is equal to y. Now we have an x-coordinate of 4 and a y-coordinate of -10. So the coordinates of point D are 4, -10. Let's do one more example. The midpoint M of PQ is 3, 9. Find P if Q has coordinates -2, 5. Now in this question, the midpoint M has coordinates 3, 9 and Q has coordinates -2, 5. We need to find the x and y coordinates of point P. So let's write down these coordinates as x and y. Now we can use the formula. We know that the x-coordinate of the midpoint M, let's say mx, is equal to the x-coordinate of our first point plus the x-coordinate of our second point, all over 2. Let's say that Q is our first point and P is our second. The x-coordinate of the midpoint M is 3, so we say 3 is equal to the x-coordinate of Q, -2, plus the x-coordinate of P, which is simply x, all over 2. And now we can solve for x. Let's multiply both sides by 2, and we get 6 is equal to -2 plus x. To get x by itself, we need to add 2 to both sides. 6 plus 2 gives us 8, which is now equal to x. This is the x-coordinate of point P. So let's find the y-coordinate. We know that the y-coordinate of midpoint M is equal to the y-coordinate of point 1 plus the y-coordinate of point 2 all over 2. The y-coordinate of point M is 9. We make this equal to the y-coordinate of our first point, which is 5, plus the y-coordinate of P, which is simply y, all over 2. And now we can solve for y. Let's multiply both sides by 2, and we get 18 is equal to 5 plus y. To get y by itself, we subtract 5 from both sides. 18 minus 5 gives us 13, which is equal to y. Now P has an x-coordinate of 8 and a y-coordinate of 13. So we can write our final answer as P with coordinates 8, 13.